teacher to our final report presentation. In this course, we using machine learning algorithm for human activity cognition and LD4 detection using MPU standard data. And our group have two members, Nguyen Thanh Tu and Nguyễn Long. And this is our presentation now live. We have four parts: problem definition, self-selected HDR dataset, applied machine learning algorithm, and real-time inference. Nowadays, there are 50% elderly stroke patients have a history of fall, and 30 fell in the past 50 months, and many ones fell more than once, and most fall occur in bathroom and bedroom, and 90% identified at high risk of falling. From that statement, we want to design a system applied machine learning to classify human action and detect LD falls in real time, providing notification and monitoring post for condition.
First, we will describe our data. Our data will collect from the MPU sensor, including 3 axes of acceleration and gyroscope signal. Each sequence contains 40 time step and 6 columns of feature. We sample 50 millisecond per sample sampling rate for capture the most right data. We collect data in 30 seconds for long duration sequence, long activity such as walking, lying or standing, and 2 seconds each short activity like fall or stand up, sit down. In this dataset, we will have 5 activity class as walking, standing, lying, stand up, and fall. And for unknown, this is our data sample. As you can see, standing activity quite remain, and fall activity have a big skew. Our data distribution in training and test dataset, all the labels are distributed quite perfectly with more sample in train dataset than test dataset. After get the input data, we will we will apply a feature extraction layer as we compute mean, standard deviation, minimum, maximum, skewness, and kurtosis for all 6 column feature raw data. Then we apply this score normalization to extract extracted feature. After that, we visualize the scatter of data by using PCA and TSNE to reduce dimension. The TSNE results show that data has been separated perfectly, although there are some overlap sample between walking and stand-up label. This is our extract feature correlation matrix. It shows that the feature 24, 25, 26 to 29 has a big correlation coefficient with feature from 0 to 6. That means the median feature more correlation to the mean feature so that we can cut off some median feature to reduce the feature dimension, the number of feature. After cut off some feature, we apply machine learning algorithm and see how several feature have the importance to the model. The image show that all 30 second, 32 feature are somehow very important to all the three model, so that the feature set are generalized enough. Here we have the flow chart or block diagram of our system. First, the data collected from MPU sensor and using ASP22 will separate into training and cross-validation phase. In training phase, we compute feature extraction, then calculated loss between actual label and predicted label. After that, we separate the train data into 5-fold cross-validation to evaluate the model. And finally, we apply testing phase with real-time testing.
So in this project, we apply 4 algorithms, which is KNN, logistic regression, random forest, and SVM. We move to the first model, KNN. KNN is the model that when the new data go into as the input, it calculates all the distance from the new data to every point of the trained data, and using a majority voting to decide what the label of the new data is. As you can see on the plot, at k equal to 6, the model has the highest accuracy, and this is the result of the KNN model. The next one is the random forest. Random forest is a large number of decision tree, and the label of the new data decided by majority of the tree. And at 3 equal to 100, the accuracy achieved at 0.98. And we move to the next part, is the random forest result. As you can see, the result is very high and good because the large of the tree. The third one is the logistic regression. It's a statistic machine learning algorithm. It's using a softmax action function to classify model into a binary option. And as you can see, the accuracy of logistic is lower than decision tree random forest. And we move to the next part. It's the final one, the support vector machine, which is a supervised learning algorithm that's find the optimal hyperplane, separating classes in the feature space by maximizing the margin between data and the data or between different classes. And this is the result of the model, and we will compare between 4 models, and random forest is the highest, and next to it is the logistic regression, and this is 4 confusion matrix between 4 models.
In the 4 confusion matrix, as you can see, random forest have the nearly perfect diagonal, but logistic regression and SVM has more accuracy in the fault detect label. Besides, logistic regression and SVM are quite lightweight than random forest, so we can conclude that logistic regression are the most suited model for the system.
Because logistic is the most suitable model for our project, so we will choose logistic to embed in the MPU in the SP32 microcontroller. We apply data into two ways. First one is on-device processing and remote processing. We move to the on-device processing. On-device processing, we will train model on Google Colab and export model as Joplib. After that, we convert model to C using M2C Gen. The data from the sensor will feature extract and normalize and fit into the model, embed into the ASP32, and we will real-time inference on device. Next one is remote processing. In a remote processing approach, data from MPU transmit into ASP32 using MQTT protocol, and the computer acts as both the broker and subscriber, while ASP function as the publisher. And when this data is received, they are feature extracted, normalized, and fed into trained model for inference on the computer. And this is the inference result, real-time inference result. Conclusion: remote will support complex model, easy to update and monitor. We will have higher computing power. On the other hand, local have low latency, can work offline, and have good data privacy. The cons of local is limited resource, it lower to flexibility and hard to update. But remote require network and have higher latency and really have possible to privacy issue. So we conclude that local on device will best for real time and low power HAI, and remote will suitable for development and advanced analysis. And thank you for your attention about our presentation.